Hey there, welcome to my Advent of Code General Guide. Before we get started, I just wanted to say a huge thank you to everyone for 100 subscribers on my YouTube channel. Honestly, when I started this out, I imagined I'd just have a couple of people who maybe watched it every now and then. I did not expect to get so much support so quickly, so thank you all so much. If you enjoy my videos, please like, and if you'd like to continue to see them, please be sure to subscribe. It helps me out a lot and motivates me to keep producing content for everyone. So let's get into this guide, and if you'd like to read along with a text transcript, I'll leave the link to it in the description. It's up on my GitHub in the Advent of Code repository. And in addition to what's just on the text transcript, I'll also go through the last problem from 2021 just as a bonus in 3 different languages. So in case you don't know what Advent of Code is, it is a 25-day programming contest, and each day a new problem is released at midnight in Eastern Standard Time. So that's 5 a.m. in UTC time. And each problem has 2 parts. Each part gives you a star when you solve it, and the goal is to get all 50 stars. And on top of that, the first 100 people to get the right answer for each part get between 1 and 100 points depending on speed. And there's a global leaderboard overall. So, for example, that's what this looks like right now. We've had 5 days so far, so the maximum theoretical score would be 1,000. So you can see number 1, Betaveros, is actually very close to that. He always does very well on these, and I'm currently in 10th place. So if you're here, you've probably already heard about this, but if not, here are some reasons I'd recommend you participate in the AOC. First of all, there's a really great community out there for it. You have a lot of like-minded people who are passionate about programming and enjoy challenging themselves, and even if you're a complete beginner and completely new to this, you will find yourself very quickly welcomed into the community. And make sure you check out the official subreddit. There's a pretty big community here. I'll leave the link in the description as well, and they are also pretty amazing. Secondly, the challenges don't require very difficult concepts, algorithms, or data structures, but they are still good challenges to both your programming skills and your problem-solving ability. So, while especially the later days are not really suitable for like complete beginners, it doesn't require you to have higher level competitive programming or computer science knowledge. It's something that's very approachable for people who have more general experience, and it's great for developing your problem-solving ability. So unlike a lot of contests that require you to have a pretty broad repertoire of algorithms and data structures, the Advent of Code does still require you to know a couple here and there, but it's a lot more about on-the-spot problem-solving and less about recalling memorized algorithms. Thirdly, the daily format, in my opinion, is very good for pacing your problem solving. I find that often the hardest part about practicing is actually getting into the practice routine. So it's easy for me to get a lot of motivation and go through a bunch of problems in one day, but that isn't necessarily the most helpful, because I might not learn as efficiently from everything I do, plus I might run out of problems that way. And the worst part about that is then sometimes I don't have motivation to do them on other days. And so the competitive daily format sets you up for a routine very well. Finally, if you're interested on the competitive side, the leaderboard is quite competitive, and it's pretty fun for me to try to aim for high ranks, either on the daily leaderboards or on the overall global leaderboard. Even if you're not interested in that, the challenge on its own is very enjoyable, even if you do it just completely in isolation, and you can totally ignore the leaderboard and just challenge yourself. And that's what I'll get into next. So, before we start actually talking about how to go for leaderboard spots, because this guide is mostly about how to aim for fast times, although it does also contain some more general tips. Firstly, the leaderboard might not be for everyone. Your primary motivation for doing the Advent of Code should be because you find it fun and want to challenge yourself and learn, or because you like the community and want to participate in this, or because you like coding, or literally anything. If you're motivated because you want to go for the leaderboard rankings, that is completely fine, and I encourage you to go for it. Just don't let the competition get in the way of actually enjoying the process and learning something out of it. And on top of just the leaderboard, consider also challenging yourself in different ways than just coding speed. That's what the leaderboard measures, but you can do all sorts of things with it. You can try a new language that you've been wanting to learn. You can optimize for speed or resource efficiency, because that's usually not what's focused on by people who go for leaderboard spots. Try to find a more creative approach, or do things like visualizations, or literally anything else you can think of. For example, on the subreddit, there is a tag, flare I think they're called Upping the Ante, which is dedicated just to people who make solutions that go above and beyond just solving the problem directly. So if we go for the top of all time on this one, somebody, I forget exactly what this problem was about, but somebody basically plotted out all of the points on a folding phone and then literally folded their data set. And I don't exactly remember what the problem was about, but that's just pretty funny and creative. And so that's one example. Somebody even wrote a paper on one of the problems, which I found really incredible. Okay, I'm not very good with Reddit, so I don't know how to filter by the flare and also look at top of all time. But yeah, so people have come up with stuff like data visualizations, writing papers, working on hyper-optimized solutions that can solve it way faster than everyone else's. Those sorts of things you can also challenge yourself with. Most importantly, don't let the leaderboard ranking define yourself or your worth as a programmer. Being fast at coding, I'm not going to say it's a worthless skill, but there are so many different skills that you could have, and no one person is the best at everything. And measuring speed is a very reductive metric. There are a lot of factors that you might not even think about, like your language choice will greatly affect your performance each day, your computer specs as well, and your internet speed. English language comprehension is another huge part. Part of getting fast leaderboard spots isn't even being fast at coding, it's being fast at actually reading the problem. And so people who are more proficient with English are obviously going to have a huge advantage. Typing speed is also another big one. So as long as you have fun and think you're learning or gaining something out of it, then that's excellent. And the leaderboard spot should be secondary to that. So let's say you've decided that you want to do the AOC and that you are interested in challenging yourself for leaderboard rankings. So that's mostly what this guide is going to be about. Again, I'll have some more general tips throughout. But there are some important factors that you should consider before you actually think about the problem solving itself. So firstly, be available. It's extremely obvious, but you need to make sure you're ready at the exact moment the challenge starts. Especially in the first few days, even just missing 1 minute probably means you have no chance of getting on the leaderboard. So make sure you've established your schedule and make sure that routinely you are able to actually be at your computer, have all your distractions off, and be ready to start as soon as the problem is released. Secondly, you want to make sure you have everything set up. So you should have your text editor or IDE, whatever you're running your code in, such as your terminal, the Advent of Code website window, anything else you think you might need. Make sure you have all of those open well in advance and make sure your entire setup is complete. So as soon as the problem is out, you can just immediately start solving and you don't need to open or find any other resources. And finally, try to make sure you won't run into technical issues. Now, of course, there are going to be some unpredictable things, but for example, make sure your computer is up to date so that Windows won't randomly restart on you. Make sure that people don't restart or shut off the internet while you're solving, or start downloading something while you're computing, things like that. Overall, just make sure you have everything prepared so that you are challenging your problem-solving skills and not your ability to adapt to random situations going on around you. Now, the next important part you should consider is programming languages. So my personal recommendation is Python, because it has a lot of important built-ins that you'll find very helpful. It also has very low verbosity and overhead, meaning that you won't need to spend a lot of time writing out a bunch of long code just to do simple tasks. There is a performance difference. It is significantly slower than C and C++, but this doesn't really matter because it's, for the early problems, it's going to be fast even if you're even if you implement a horribly inefficient solution in a very slow language, because the first few problems are just computationally not that expensive. And for the later problems, if you have a good algorithm, you might get a few seconds of difference between Python and C, but later on a couple of seconds almost always doesn't matter for more than maybe a handful of leaderboard rankings if you're unlucky. And if your algorithm isn't efficient, C and C++ aren't going to run in time. There was one problem from last year, I forget which one it was, or maybe it was even a couple of years ago. If you wrote the straightforward brute force solution, even in the fastest language out there, it wouldn't be done running by now. So if your algorithm is faulty later on and it's too inefficient, your language choice isn't going to save you. And finally, it has a lot of very nice language features that I think are just really useful. So let's open up Python, for example. So one thing that's very helpful, for example, is easy string manipulation. So looking at the input for 2022 day 5, for example, and I'll go over this more in detail later. The input format was something roughly like this. And so how would you read the letters out of each of these? Well, you could split by spaces and then drop the brackets, something similar to that. There are a lot of ways that you could do it, and it's not an extremely complicated task, but it's just so trivial in Python. You can just start at the first index and grab every fourth element. It is as simple as that. It also has built-in set operations. So for example, if I have the set 1, 2, 3, and I want to take the intersection with the set 2, 3, 4, it's just a single ampersand, and it's very convenient. Built-in complex number support is also another one, and I'll talk about that a bit later. And infinite integer precision. You can have arbitrarily large numbers in Python, and you won't run into precision issues. JavaScript is another very good language. It also has a bunch of useful utilities, and sometimes it might even be easier than Python because of the way nested calls are handled. So let's say we have 3 functions. So the first function will take x and return x plus 1. The second function takes x and returns x times 2. And the third takes a number and divides it by 3. So not very interesting overall. But let's say you want to call f and then g and then h on every element in an array. So let's say x is an array, and you want to map f and then g and then h. In JavaScript, you take x, you call .mapf, that gives you your numbers plus 1, then you put .mapg after that, and then you put .maph after that. So it's quite nice, it goes linearly. In Python, on the other hand, let's say we have the same functions. Then to do the same thing, we'd have to do map h over map g over map f on x. Oh, sorry, I need to define x first. So it's still not too bad, but most notably, you have to nest the call. So here we never went beyond depth like 1. We just chain them linearly. Here we had to nest the calls within each other. So that can get a bit ugly. It can be hard to manage where your brackets are, and you can run into weird bugs if you slightly misplace your brackets a bit. So while I'd still recommend Python, if you're using, you can also consider JavaScript if it's something that you think you'd be a bit more comfortable with. And the thing I mentioned about infinite integer precision, JavaScript does have that too, not with standard numbers, but if you put an n after it, it turns into a big int, which does have infinite precision. Also, you may have noticed this while I was typing those functions out, but JavaScript's lambda syntax, like that, is a lot nicer than Python's. Like, I don't know why Python's is like this. It's really ugly. Okay, of course, feel free to use any language you'd like. For optimal leaderboard positions, you probably want to pick a high-level language instead of something like C or C++. That'll have a lot of overhead just for reading the input. But again, if you're looking to learn a new language, AOC might not be a bad way to get familiar with some of its features and try a bunch of not overly complex coding challenges that are more about the problem solving than the implementation. And regardless of what language you pick, the most important thing is to be very familiar with the language. And you want to have a very solid understanding of the language and know all of its quirks and features that can help you save time. Because even if your solution is a bit hacky and sort of abuses some of your language's features, if it's fast to write, that's all you need when it comes to leaderboard rankings. And again, I do say that you should have a very solid understanding, but if you're using it to learn a new language, that can be very beneficial as well, to develop that solid understanding. Obviously, you can't expect good times, but that is far from the main reason you should be doing the AOC. The following bit is Python specific, since that's my language of choice, and the rest of my tutorials are all in Python on the advent of code walkthroughs. But here are some Python specific tips that you might find helpful. So you can open standard input as a file using open0 like that. And so let's do an example. So if we print open0.read like so, recalling that .read just reads all of the content in a file, we can do that and then enter all of our input, hit Control D to terminate it, and we get our input back. So it's essentially the same thing as importing sys and then printing sys.standardin.read everything. It does the same thing, but it's a lot easier to use. And since you're opening it like a file, you can also iterate over it. For line in open0, print int line. That works as well. We can also print line +1 just to show that these are actually integers. So you can iterate through your line like that, which is pretty convenient. Just do keep in mind that the line does come with the trailing new line. So if I type hello, you'll notice that there are two new lines because print outputs one on its own, and the line has an extra. So if I print the length of the line, you'll notice that hello comes out as 6 instead of 5. So just be careful of that. Also, let's say you have an iterable. So let's say I do input.split, and then I do 1, 3, 4. That gives me a list. So if you want to do like a equals input.split, and then x equals a at 0, y equals a at 1, z equals a at 2, that works, but you can also do x, y, z equals a, like so, and it does the exact same thing. So you can unpack a Python assignment like so. And one of the common applications for this is, let's say you want to take two space-separated integers. Let's say they're coordinates. X, y equals map int over input.split. I've used this exact line of code probably hundreds of times. And now x is 2, y is 3. Thirdly, a good feature to be familiar with in Python is sets. So if you have an iterable, let's say an array, you can create a set from it using the set function or constructor like so, or you can use curly brackets and type in the values directly. Do be careful that if you have empty curly brackets, that is actually a dictionary, not a set. So just be careful of that. To make an empty set, you just call the set constructor on nothing. So here's one important thing to know about sets. They cannot have duplicates. So if I convert the set 1, 1, 2, 3, 5 into a set, you just get 1, 2, 3, 5. Let's say x and y are sets. So 1, 2, 3, 4, 5 for x, and y is 3, 4, 5, 6, 7. The main reason that Python sets are so nice is because of their built-in set operations. So x ampersand y gives you the intersection, all of the values that are in both sets. X pipe y gives you the union, all of the values that are in either set. X minus y gives you the set difference, so that's everything in x that's not in y, so that's just 1, 2, and y minus x is just 6, 7. And finally, the symmetric set difference, which is elements that are in either set but not both. So these are extremely convenient. You'll run into a handful of problems through AOC that require you to find intersections or combine two sets together without duplicates. Python sets do that all for you. Fourthly, Python has native complex number support. So 1j, or any integer, sorry, not necessarily integer, any number followed by j gives you a complex number. If you're not familiar with complex numbers, you can look those up. They're not exceedingly complicated. You can just think of them as two-dimensional numbers. You have a real component and a complex component. And the arithmetic with them is, at least addition and subtraction are fairly straightforward. Multiplication and division get rather complicated. But I'm not going to go over complex arithmetic in this tutorial. The main thing they're really helpful for is coordinate calculation. Let's say you have two coordinates, 2, 3, and 5, 2. If you want to get the offset between them, let's say x equals 2, 3, and y equals 5, 2, you'd have to do y0 minus x0, bracket y1 minus x1, like so. But if you represent them as complex coordinates, x equals 2 plus 3j, where we'll use the real component 2 to measure the first coordinate, and 3j, the complex component, to represent the second, and then y equals 5 plus 2j. Now if we do y minus x, that gives us the exact same. 3 is the real component, the horizontal offset, and negative 1j, or just negative 1, is the vertical offset. Another really nice thing you can do with these is rotate them. So x is 2 plus 3j, which, let's bring up a whiteboard quickly. So on our Cartesian grid, 2 plus 3j could be represented as like 2 is the x coordinate and 3 is the y coordinate. So 2 plus 3j. Now if we want to rotate that counterclockwise by 90 degrees, if x were represented as 2, 3, we'd have to do like negative x1, x0. It's a bit of a pain just to even remember how exactly that works. But if we have x represented as a complex coordinate, we can just multiply x by 1j. And again, this is a feature of complex arithmetic that I won't really go into, but multiplying by I or j rotates counterclockwise, multiplying by negative j rotates clockwise, and of course negative x just rotates by 180 degrees. So again, look more into complex numbers on your own. If you're not familiar with them, I would highly recommend it. But the main things you want to keep in mind are just, you can do addition and subtraction to get offsets, and you can multiply by 1j to rotate counterclockwise, and negative 1j to rotate clockwise. Finally, once you want to convert those back into the actual components, x.real is the real component, x.imaj for imaginary is the complex component. Just keep in mind that they're floating point numbers, even if the underlying values are actually integers. And the final component is understanding list slicing. So there's a good page on this feature on Geeks for Geeks that I'll leave in the description as well. But as a summary, if we have some array, then A from X to Y jumping by Z means take the elements of A starting at index Y, ending at and not including starting at index X, ending at and not including index Y, and jumping by Z each time. So if we want to get every other element starting from index 0, we can do X starting at 0, going until the end, which we can indicate by just leaving it blank, jumping by 2 each time. Sorry, that's meant to be A. So that's every other element starting from index 0. And starting from index 1 would be like that. Let's say we want the list backwards. Well, we start from the end, which we'll leave out, which I'll explain why in a second. And then we want to stop at the beginning, which I'll also leave out. And then to jump backwards, we do negative 1. And so here's why we could leave out both the X and Y. So if your increment is going forward, like so, then it automatically starts at the start and ends at the end. And if your increment goes backwards, then it automatically starts at the end and ends at the start. And so you can include either the start or the end manually, but if you leave them out, it automatically infers which way to go based on the direction of your increment. So the most important one in my opinion, to keep in mind is just the : -1. That reverses a list or a string. You can also address strings like so. It's just very convenient as a shorthand. And this is the same thing I was talking about earlier with being able to unpack. This is just starting at the first index and then jumping by 4 each time. Okay. So we've looked a bit into language choice and some Python specific features. Now let's talk about some things to keep in mind that aren't related to the problem solving component directly, but are still related to coding. So to be fast, you obviously want to avoid losing time on common pitfalls. And so here are a couple that I can think of. So firstly, you want to make sure you test your code, unless you're like extremely confident that you can't possibly have gotten it wrong. If it takes you 5 seconds to test your coding as the sample input, then so long as you catch a bug with this 1 out of every 12 times, it's worth the time, because the first incorrect submission forces you to wait for a minute, and it gets even longer if you mess up again. So I have a couple of tools that assist me with this. So firstly, I have a user script made by user TJJFVI, which I'll link in the description as well, where if I right click on a code block, it will copy it. So I right click it, it flashed green, and then I just go into my workspace and paste it here. And that's the second thing. I have 2 separate files, in.txt and test.txt, which means that I can then go to my puzzle input, copy that, move that to in.txt, and now just as a demo, I'll just print the length of the input. And the last thing is I have a utility command, AOC, which runs my program on the test output and prints it in blue, and then runs my program on the real input. And that sort of looks like this. So that's sort of what that looks like. So I have AOC, which runs the test script and the submit script. The test one just outputs the ANSI code for turning text blue, runs my file on test.txt, and the main one just runs on in.txt. So I can also do AOT just to get the test output and AOS just to get the, the actual output. So you probably shouldn't be copy pasting this, but do consider writing similar utilities to help yourself test the code. With all of these things that I use combined, it only takes me about a total of 3 seconds max to test. I can copy it for no time loss because I'm going to need to look at the sample input anyway, and I can just right click it while reading everything else. I can paste it into text.txt without losing much time, and when I run my execution command, I just read the test output, so it really doesn't take me any extra time. You don't need a setup quite like mine, but just getting into the habit of testing every day means that you'll catch these bugs before you go to submit. And once you get into this habit, you'll become fast at doing the process. And that way you won't get hit by the throttle. So as an example of why this is important, I didn't do this on day 1 this year, and I ended up losing a very easy leaderboard position. It wasn't even a bug in my code, it's just that I submitted my file in CRLF instead of LF. That's the line ending. And so my input had extra stuff that I didn't want in it. That only took me like literally 5 seconds to fix, but I had to wait an extra 55 seconds to be able to resubmit and ended up only getting around 300th. The second one is to avoid simple bugs or like common mistakes. So obviously bugs are going to exist. You can't just choose to not make mistakes, but you can change some things to avoid some more common bugs or mistakes. And the first one, ironically, most people run into it because they're trying to be fast, and then it ends up slowing them down. So you want to avoid meaningless variable names. Some people name their variables just A, B, C, etc., and then accidentally use the wrong one or redeclare one. And especially in a language like Python, where there's no difference between declaration and reassignment, and you also cannot make constant variables. This can cause some very painful bugs that don't always result in errors. Sometimes they're hidden and it just takes you forever to actually figure out why your calculations are wrong. So I still do use a bunch of single letter variable names, but you should have a convention for it. So for me, typically when I run into problems where I need to accumulate a bunch of values and then process them at the end, I'll make my list called A for array. The reason I don't use the letter L is because it looks too much like 1. And then I can do like for line in open 0, do some processing, maybe append a new value to A, and then do something like print sum of A. If I need to have a global total, I usually use T. So it might look something like this. T for total, of course. A lot of AOC problems require you to output a total or a count, so I'll always use T for that. I reserve I for loop indices and never use them for other variable names, etc., stuff like that. If you're confident, using single letter variable names doesn't mean you'll necessarily fail, but you should be careful. And if you can't always keep so good track of all your variables, try using more meaningful names. Also, a bit of a special case, I'd recommend you not use X, Y for 2D array indexes. R and C, in my opinion, are just better. They stand for row and column. You're probably used to X representing the horizontal position. But if we have a 2D array, and this is usually how you'll visualize them, you'll notice that the first index refers to which sublist you're in. So the first index is actually the vertical position, and the second index is horizontal. So you either have to do array at, you'll either have to do like AYX to make it make sense, or you'll just have to get used to having your positions reversed. But if you just do R and C, then you don't run into the conflict with it and what you already know with X being horizontal. This is very easy. It's just the row number and then the column number. Finally, don't use different variable names for the same thing. And I mean, this is obvious within one file, but like across all the code you write. Keep your naming scheme consistent, and your brain will keep track of them more easily. If you come up with your own conventions, you'll eventually be able to assign and recall what you named each variable instantly without making mistakes. Another thing is control flow. You might be tempted to copy-paste a line of code to be faster, and this is sometimes faster than taking that code, extracting it into a function, and then calling the function back from where you removed it from. But just keep in mind the risk of copy-pasting code, because if you notice an issue with one of them, you'll have to change the other one or maybe multiple instances, and that's assuming you even remember where the other instances are. So just like with the variable naming tip, I'm not saying that you should never copy-paste code segments, just be careful. And you should use functions for longer segments, especially if you think you might need to change them later on. And this is especially relevant in the advent of code for another important reason. Part 2 of problems is usually a minor variation of part 1. If you copy-paste code, you might find yourself needing to change a lot of stuff. Whereas if you extract it into functions, sometimes your part 2 solution will literally be just a couple of characters different from your part 1 solution. The last one for this section on avoiding simple bugs is to simplify stuff and don't over-optimize for anything. So this probably sounds a bit too obvious, but the simpler your code is, the easier it is to find bugs in it and change it. But it's actually important advice in my opinion. Sometimes I simplify my code to the point of it almost becoming a bit less efficient because I'm still sure it will run quickly enough, and most importantly, I'm confident that it works. If you need to make some calculation or some computation, and you have a method that you know works but might be slightly inefficient, you're probably not going to be slowed down enough by it that it actually matters, although you shouldn't assume that. You should be a bit careful. Moreover, if you stop to think about another method, this might actually result in more bugs. Because if you think about multiple approaches, you're more likely to make a mistake while thinking. And that last sentence probably sounds a bit silly, but I found that writing the first thing I think of, as long as I know for a fact that it will work, even if I know that there's probably a smarter way to do it, is usually better, because the alternative would be to break my train of thought and interrupt my own brain from continuing with the remainder of the problem solving. and stopping and breaking my own stream of consciousness isn't only slower, but it also might split my thoughts from the first half and the second half, and cause me to run into bugs from failing to continue this solution correctly. So just sort of like, if you get into the flow, as long as you're not writing code that straight up won't work or is extremely slow, it's better to stay in that flow. The next tip I have is to catch your bugs early on. Because, like I said, you can't just decide to not have bugs, but you should try to catch them as early as possible. And I'll mention this a bit later as well, but try thinking in stages. So instead of just thinking of the problem as a whole, think, okay, so I have this input. How do I get the input into the format that I want? Once I have it in this format, how do I process it step by step until eventually the last step is the computation that gives me my answer? So let's look at 2022 day 5 as an example of this. So I won't go over the problem exactly. You can find my walkthrough video on this if you want, but one of the more difficult parts of this problem was actually reading the input. So here you'll see that the input is represented as a bunch of stacks displayed in ASCII art vertically. So the first step is obviously to process the first half of the input. So I did that and then printed out what data I had stored. It turns out that I wasn't doing my input processing quite correctly. And actually my stacks were upside down compared to what I needed from the algorithm that I was going to implement. This would have potentially been extremely annoying to figure out if I was looking at the final output and it was just straight up wrong, because that could indicate a bug in anywhere in your code. But each time you complete a step, print out what you have so far and see if it looks right. That way you can catch errors basically immediately, and you won't have to dig through your intermediate steps at the end. Also, once you test a section, don't get rid of the test code. Just comment it out. If you do run into a bug at the very end and your last section doesn't seem wrong, go back and uncomment stuff and see if you can find a bug at a different point in time. So that's all for the meta tips. Let's move on to some of the actual coding part itself. I'll try to be language agnostic, but sometimes I will refer to a couple of things that are more specific to Python, but generally you can probably still apply them in other languages. The first tip I have is using regular expressions. Now, regular expressions can be a rather divisive topic. Some people think that you should basically always avoid them, but sometimes they're the easiest way to parse the input. So for example, looking at 2022 day 5 again, this part, you get a bunch of move x from y to z, and you can split the input and extract the indexes. So for example, if I have the line move 1 from 2 to 1, I can do x.split and then map get every second element starting from index 1 and then map int over that. And that's actually pretty easy. You can also just find all instances of a sequence of digits. So if you import regex, then you can do list map int on re.findAll, the regex for a sequence of digits, and x. Now you might be wondering, what's the point in doing that? It's literally longer. Now, in this case, the first one is actually shorter, but the main reason you want to go with the second, potentially, is it's more consistent. Because let's say I suddenly change the input format such that it says like x equals move one object from the stack numbered 2 to the stack numbered 1. Now you'll have to count and figure out which index the numbers are in, and you won't be able to do the fancy slicing thing anymore, and it'll just be very inconvenient. But this line of code still works. So, fitting back into the avoiding bugs theme, you don't have to worry about making indexing mistakes. As long as the actual text content doesn't matter and you just need the numbers in order, this can be a lot easier. And there are a lot of other similar applications where you can use regular expressions to scan for certain parts in your input while ignoring everything else regardless of its index or size. For the second one, don't be afraid to use hacky solutions. So fair warning, this will contain spoilers. For day 4, part 2, it asks you to check if two intervals overlap. Now, this isn't actually very hard to calculate. If your first interval is AB and your second interval is XY, it's just A less than or equal to Y and B greater than or equal to X. So that's pretty simple and fast. But the way I did it was essentially, let's do an example. So A equals 5, B equals 7, C equals 7, X equals 7, Y equals 9. So to check if these overlap, again, it's just X less than or equal to Y and B is greater than or equal to X. The way I did it was I just took X, the first interval, turned it into a range, and then called set on it to get it into a set of numbers, and then called the intersection. Now, this is admittedly quite stupid, because first of all, this part works regardless of how large X, Y, A, and B are. Also, sorry, I wrote that wrong. It should be A here. So this works no matter how large the inputs are. This has linear runtime and blows up if your inputs are too large. But the crucial part is this would have taken me a bit of time to think about. This didn't. And so even though the way I wrote it is technically more stupid because it's more slow and also longer, it took me less time to write out. So if you're going for just speed of solution, don't worry about being a bit hacky. Of course, make sure your code isn't so slow that it doesn't even finish fast enough for you to submit. And don't go for something that's so weird or outlandish that you might run into weird bugs. But don't be afraid to be a bit hacky or implement solutions that aren't exactly optimal. And my final tip in this section is to go step by step. I talked about this earlier, but there's a specific reason I like to separate things into multiple steps. Firstly, it's easier to debug because you have a very obvious division of sub-problems, basically, and you can check the result in each intermediate step. Moreover, though, you're more likely to be able to find a step that's similar to something you've done before, because if you break it into a bunch of smaller and easier segments, then you might be able to identify a pattern that you've seen before, and so you'll be able to very quickly know how to solve that component. And finally, as the counterpart to that, if you break it into steps, then you also sort of are more likely to, in the future, be able to apply that step. If you just solve a problem as one whole thing, you only really know how to solve that one whole problem and anything similar to it. But if you mentally break it into steps, even if the implementation is sort of just one whole thing, if you break it into different components, you now have all of those components in your repertoire. So let's say you take a problem and you solve it via 5 different disjoint stages. Now you know how to do all 5 of those. So if you run into a problem later on that uses 2 of those 5, if you just had one whole solution that was just one thing in your mind, you wouldn't be able to apply that. But if you split it into different stages, now you'll have more overlap between problems you solve, and you'll be able to more quickly learn these patterns and these tricks for yourself. Now, the most important piece of advice I can give is going to be extremely obvious. It is literally just practice. But that's the thing, I can't really give better advice than that. The experience required for solving these challenge problems is a lot different than what you gain with regular development. And so the best way to practice for coding contest is to just do coding contest problems. And doing past AOC problems is the best way to familiarize yourself with the style of problems in the advent of code. And especially because the 2-part format is, I'm pretty sure, very unique to advent of code, there's a certain skill in knowing how to solve a part 1 in a way that it can be easily transitioned into part 2. And that's something that you can only really learn from doing advent of code problems. Even once you've solved a problem, try to find a shorter or cleaner solution or something that's subdivided into more steps, like I mentioned. And it's not a bad idea to check other solutions as well. So of course I'm going to recommend that you try checking out my solutions. I post them on the same GitHub repository that this guide is in, and on the same YouTube channel as daily walkthrough videos, as well as checking out solutions from other top-ranking users. So something important to know. On the leaderboard, if someone's name is green, it means that they've linked to their GitHub page. And so notice that mine is green as well. This brings you to my GitHub page. And and I have some stuff linked for people who are coming here from the AOC leaderboard. One specific person that I would absolutely recommend is Betaveros. He's been top rank for a while. He was number 1 in 2021, 20, and 19, and also second place in 2018. And based on the leaderboard so far, I'm pretty sure he's going to be easily top 1 this year as well. And so he has past solutions as well for a bunch of years. Interestingly, not 2021's, but he has a bunch from previous years. Okay, so to conclude the actual guide part, I've given you some meta tips and advice, but ultimately the experience and pattern recognition are probably the 2 most important parts of problem solving, at least in the context of these coding challenges. And that's stuff that I really just cannot teach. Practice is the best way to improve at anything. Hopefully, the tips that I've given you help you practice more effectively and give you some pointers on how to approach these types of problems. And especially during the contest, hopefully, if you're looking to be fast and gain some points on the leaderboard, I hope this guide was able to help you with that. So that's all for the guide part. In the next part, I'll go over 2021 day 25, just as a little bonus, and I'll do this in 3 different languages. So I'll sort of explain my thought process for the overall solution and then some implementation tricks. So if you're not interested in this part, feel free to just stop watching the video here, and thank you for watching this part. So for this part, let's look at 2021 day 25. So this is the last day, so as is tradition, there is only one part. The second part is just a free star. As long as you have the other 49 stars, you just click a button and get the last one. So you're at the bottom of the ocean trench, the last place the sleigh keys could be. This year's theme was something to do with oceans. And your submarine's experimental antenna still isn't boosted enough to detect the keys, but they must be here. So all you need to do is reach the sea floor. You touch down to the sea floor if you could, but there are 2 large herds of sea cucumbers, and there isn't an open space large enough. And you think the elves probably have done this before, and just then you discover the phone number of a deep-sea marine biologist. So they tell you, sea cucumbers? Yeah, they're probably hunting for food, but don't worry, they're predictable critters. They move in perfectly straight lines, only moving forward when there's space to do so. They're actually quite polite. And so there are 2 herds of sea cucumbers, like mentioned. One goes east and one goes south. Each location can only have at most 1 sea cucumber, so you have a grid. The remaining locations marked by dots are empty. And the submarine generates you a map of the situation, which is your puzzle input. So let's grab that first. So test.txt, we'll put that here, and then puzzle input will go here. So at each step, all of the sea cucumbers in the east herd attempt to move forward, so to the right by 1 location, and then all of the sea cucumbers in the south-facing herd try to move forward in 1 location. And when they move forward, each one simultaneously checks if there's space. So they don't move 1 by 1, they all check first, and then they all move. This is important because in a situation like this, where a bunch of them are in a row, they can't all move at the same time. All of the ones except the frontmost one believe that there is no space in front of them, and then only the frontmost one moves. And then during a single step, the east one moves first and then the south one. So in this example, the east one attempts to move first, so it can't move, and then the south one moves, which is why on the next step the east one has not moved. Whereas in the second example, the east one moves first, so it gets out of the way of the south one, and then the south one can move, so both have moved in this example. Due to strong water currents, sea cucumbers that move off the right edge of the map appear on the left edge. I think this problem writing is extremely hilarious. Strong water currents somehow means that sea cucumbers can just teleport around the grid. They always check whether their destination location is empty before moving, even if it's on the opposite side of the map, somehow. So basically just need to consider the board as cylindrical, so it wraps around. To find a safe place to land your submarine, the sea cucumbers need to stop moving first. So, given the initial state, here's it 1 step later, then 2 steps later, etc. all the way until eventually at the 58th step, no movement is made because all of the sea cucumbers are now stuck against each other. And so what is the first step on which no sea cucumbers move anymore? So let's first think about how we would approach this problem. So we're going to read it as a grid. Since we're moving the sea cucumbers constantly, it's going to be annoying to keep them in grid format. It will be both easier and more efficient to extract the coordinates of each herd and where all of the sea cucumbers are. So we'll scan through the grid character by character and add to two lists, the east herd and the south herd. Then, because each sea cucumber doesn't care which type of sea cucumber is ahead of it, it won't move if there's anything that's not empty, we can keep a 2D array of all of the spots that are currently occupied, which we can do by just taking the grid and turning all of the dots into zeros and the non-dots into ones, representing taken. Then we essentially just want to run a while true loop, each time incrementing how many steps it's been. Each time we try to move all the east ones, and then we try to move all the south ones. If none of them move, then we are done and we can exit and print the number of iterations. So the move south and move east steps will be extremely similar, so we can actually extract this to a function. And so we'll have a function that will take two arguments, which I'll actually represent as 3 in these examples. The first one is the group, so which herd is moving. And the second one is in what direction. And so each time we'll just take the group, filter it to only keep sea cucumbers that have an empty space ahead of them, and then move them all. It's important that we separate these two steps because they check first and then move. And they do this simultaneously instead of one by one. And then finally, we just return the number of sea cucumbers that moved. If there were none, then we can just exit. So let's go on to implementation. So we're going to use open0 to open the entire file, read it, strip to get rid of the trailing new line, and then split it on lines. So that converts into a list of strings, each one representing a line. And so we can just say grid equals that. Now, the number of rows, we'll represent that with capital R. Generally speaking, I use capital letters for constant numbers. So R is going to be the length of the grid, which is the number of rows. And C will be the number of columns, which we can do by getting the length of the first row, like so. Now we'll keep two herds as lists, like so. And then we can iterate through the grid and keep track of the coordinates. So we can do that with for R in range capital R, where R lowercase r represents the current row number, and for C in range C. So that will iterate through every coordinate in the grid. Now if grid at row R at column C, that's the current spot, if that's equal to the right arrow, then we'll append RC, which is the coordinates of the current spot, to the east herd. And if it's equal to lowercase v, the down arrow, then we will append it to the south herd. Now we can make a new 2D grid, which represents if each spot is taken or not. So we can just do a double list comprehension, essentially for each row in the grid and for each column in that row. If the character at that column is not equal to the dot, then that means it is occupied or taken. And if it is a dot, then we set it to false for a free spot. Now let's define our move function. So like I mentioned, I'll take it as 3 arguments, and you'll see why in a second. So the first is going to be the group, or the herd, I guess, that is moving. The second one is going to be the change in rows, and the third one is going to be the change in columns. The reason I do it like this is just to make the math a bit easier. So when we move to the right, dr will be 0 because there is no change in rows, and dc will be 1 because we are increasing the column by 1. When we manage the south herd, dr will be 1 and dc will be 0. So let's just pass for now. We'll get back to that later. And we will make this return some non-zero value if there were any movements. So now we can just set I equal to 0, the iteration counter, and then while true, I plus equals 1. And now if it is false, so if not, either the east group moves or the south group moves, then we can break. Now before I continue, there is one bug with this program already. This line of code is not correct. Can you think of why? So the reason is this keyword here, or. We want to check if any in the east group moved or if any in the south group moved. But recall that the OR keyword in Python short circuits. If the left side is true, the right side does not run. So what this means is we check if any of the east herd moves, and if so, we just return true and then skip. So we can't use OR here because it short circuits, and unfortunately Python doesn't really have a direct way of not short circuiting. But we can use addition here. Because if we return an integer value, which we will, then also on top of that, booleans are integers. True is equal to 1 and false is equal to 0. If we add them like so, this cannot short circuit because to do addition, you obviously need to know both values. And so this is essentially the same thing. If the number of movements on the east herd plus the number of movements in the south herd is non-zero, then there was a movement this step. Finally, at the end, we can print I to output the number of steps that were taken. So now let's implement the movement logic. So we first need to extract all of the sea cucumbers that can move. We'll represent that with M. So we can do this with a filtered list comprehension. X for X in group, herd, if not taken at the position. So what is the position? Well, it's not RC. It is R plus DR and then C plus DC. Basically the spot 1 ahead. But recall that sea cucumbers will wrap around the edge of the board. So we need to do this. X0, which is the R coordinate, plus DR modulo capital R. So it wraps around if it hits the number of rows. And then the same thing here, X at index 1, the C coordinate, plus DC mod capital C. One important thing to note here, which is actually intentional. This list contains references to this list. What that means is if we mutate any elements of M, not reassign, but actually modify with like dot append, for example, it will actually edit the value here. We haven't cloned the lists. We've created another reference to the exact same object. And this is intentional. We'll use this later. Now that we have the list of all sea cucumbers that can move, we move them all. So for X in M, we can use this deconstruction just to more easily do the math. So R is the row and C is the column of our current sea cucumber. Now we set the 0th element of X. This is a mutation. So even though we're modifying an element of M, this will actually modify an element of herd, which will actually modify the original east list itself, or south list here. X at index 0 is equal to the next spot. So that's R plus DR mod capital R. And the C coordinate now becomes C plus DC mod capital C. And now we just need to update which positions are taken. So we just cleared the spot RC, so that now equals false. It is no longer taken because our sea cucumber has left the spot, and taken at X0 at X1 is now true because our sea cucumber just moved here. And finally, we can just return the length of M. So this will be 0 if there were new movements and non-zero if there were. You can also really return anything. You could also do like return if M, return 1, otherwise return 0. Like anything like that would work. Return length of M is just easier. And that should be all there is to this problem. So let's run it as a test first. Python 3 main.py with test.txt gives us our answer of 58. And if we run this with our actual input, it takes a bit. We get our answer of 492. Moving on to the JavaScript implementation. So with JavaScript, taking standard input is pretty annoying. So we won't do that, and instead we'll do file input. Main.js. We'll be doing this in Node.js. So to do that, we import fs from the fs module, and then we can do what is it? fs.readFile sync of the path. And just to be able to change which file we're reading on the command line, let's do process.argv at index 0. That is just the, or sorry, it would be index 1. That is just the command line argument that we feed the command. So let's do const data equals that data that we read, and then we can console.log data.length just to see if it looks correct. So we can do node main.js, and then instead of piping in in.txt, we just put the file name in.txt onto the command line. Right, we can't import outside of a module. Const fs equals require fs instead. And if we do that, 101 is absolutely not correct. Oh, right, it's getting main.js. So it would actually be argument 2. I forgot, I think this works a bit differently than how it does in Python. Node must be the first argument, and then this is second, and this is third. So now if we run this, in.txt has about 19,000 characters in it, and test.txt has about 99, which seems correct. So that now gets us our data. So we're going to get the grid, which we're going to obtain by taking our file input, trim the trailing new line off, split it on new lines, and that should mostly be it. Now, just like with the Python solution, we'll let R be the number of rows, and we'll let C be the number of columns, which we can obtain by getting the length of the first row. And now we'll keep track of our two herds in two separate lists, arrays like so. So now we iterate through the grid. So for let r equals 0, r is less than capital R, r++. Same thing goes for C. If the character at the rth row in the cth column of the grid is right arrow like that, then it is part of the east herd. So we do east.push rc. And similarly, if it's a lowercase v, which is the down arrow, then it's part of the south herd. Like so. Now we want to get our 2D array that represents whether each spot is taken or not. So to do that, we can take grid.map. For each row, we map again, where for each character, we return whether or not that character is the dot. So if it is a dot, then it is free, so taken is false. And if it is not a dot, then it is occupied by a sea cucumber, so taken would be true. And here I remember that I need to supply a encoding, otherwise it will read it as a buffer. And also row.map is not a character. Sorry, it's not a function. I forgot about this. So row is a string, so we need to convert it into an array for it to be iterable. So we can just use this syntax to convert it into a list, an array. And so if we log taken, we now have a large 2D array of a bunch of false and true values representing whether or not each spot is taken or not. So now we want to have a function to move our herd. And we'll take our direction argument as dr and dc. Dr is the number of rows that we change, and dc is the number of columns that we change. So when we move our east herd, we'll have dr equal to 0 and dc equal to 1 because it moves to the right by 1. And when we manage our south herd, we'll have dr equal to 1 and dc equal to 0. So let's come back to this later. And we'll make this function tell us whether or not anything moved. So return some true-like value if anything moved, and some false-like value if nothing moved. Now we can just run a loop. So a for loop for let I equal 1 automatically continues, so we can put it true here, or this is actually the same thing. And then I++. We keep track of if we had any moves in this step. So you might be tempted to do something like this. So if there were no moves in the east herd going right, and there were no moves going south in the south herd, then we can console.log I and break. But there is a very significant bug with this. It's the same as the Python one. This will short circuit. So if there were no moves in the east section, then it will skip this part, which is wrong because the east section might have no moves, but the south section might move again, and then the east section might be able to move afterwards. So we can't use the short circuiting one. And fortunately, JavaScript has a non-short circuiting one, the single ampersand. This is actually the bitwise AND operation, so it isn't the same as logical AND. So 3 ampersand 5 will give you 1. And the reason for that is because 3 is represented as 0, 0, 1, 1 in binary, and 5 is represented as 1, 0. So if you take the bitwise AND of those, then you get 0, 0, 1, which is why 3 and 5 is 1. But that's fine, because if both of these values are, because we're using the not operator here, this will get coerced into a Boolean either way. And when you use Boolean values, this works fine. It will still give you a 0 or a 1, but it's the same thing. The most notable part about this is it won't short circuit. It will evaluate both sides before combining them with AND. So now let's implement our move algorithm. So we'll want to keep track of which sea cucumbers are able to move. So const m equals the herd, and then we will filter for each sea cucumber if its spot is not taken. So that is not taken at the index that the sea cucumber is trying to move to. And so the position it is trying to move to is r plus dr, or sorry, x at 0 plus dr. But since it wraps around the edge of the grid, we need to do modulo r to wrap it back around. And likewise, x at index 1 is the c coordinate plus dc mod c. And so that filters to give us the sea cucumbers that are able to move. And just like with the Python section, note that this keeps references to the same object. So elements of M, if we mutate them, we're also modifying the exact same elements within herd because we haven't created copies of each of these coordinate pairs. We've just created a new reference. So now we can loop through each of these. For const x of M, let rc equal x. That just makes the math a bit easier. Now we can mutate x. So the r coordinate becomes r plus dr mod capital R, which moves it by either 1 down in the case of south or 0 down in the case of east. And likewise, we change the c coordinate to be c plus dc mod c. And finally, we just need to alter the taken grid. So we just cleared up the spot rc because the sea cucumber left there. So taken at rc is equal to false now. And finally, taken at x0, x1, which is the new location of the sea cucumber, that becomes true. And so we can run that on our test. That is not correct. Oh, yeah, because I forgot to return the value. So we need to return something that's true-like if something moved and something that's false-like if nothing moved. So we can just return m.length. Or honestly, we could just we cannot return m itself. We return m.length. That will be 0 if m was empty, m being the set of moving sea cucumbers, and it will be non-zero if m wasn't empty. So that gives us our expected answer of 58. And with our real input, it gives us 492. This one is actually significantly faster than Python, which I wasn't really expecting, to be completely honest. Okay, and the final language I will go over this problem in is C++. So this one is definitely a bit more challenging, just because C++ is a harder language to use. So to begin, we'll want to include three libraries. So we want IOStream to be able to get our input. We want utility for the pairs of coordinates, and we'll want vector, because we won't know ahead of time how large our grid. We won't know ahead of time how many sea cucumbers we have in each herd, so we need an extendable array for that. Normally I don't recommend this, but for challenge problems it usually saves you time typing, so let's use namespace standard. And let's declare our move function first. So what will our move function need? We'll want it to return an integer which represents how many sea cucumbers moved. And so the first thing we want is the herd. So we're going to want that as a reference, and each herd is going to be a vector of pairs. But recall that we want to be able to mutate the pair within the move function. So we're actually going to make it a vector of pair pointers. Like so. Next, we want to have our taken grid. Now, I'm sure there's a way to represent it as a grid, but I found it easier to just represent it as a flat array. Basically, all of the rows are dumped into the array back to back, and we use a bit of coordinate arithmetic to calculate what position each coordinate is represented by. So we will just have a single array of Boolean values. Next, we need to take R and C because those are not going to be global values. Although we actually could make them global, so let's actually make them global. And finally, we're going to have dr and dc, which are the offset values for how far we're moving our sea cucumber. Or specifically in this case, just whether we're moving it right or down. Let's come back to this later and get to the main function first. So we'll start our row and column at 0. Unlike with the previous two languages, it's not really too feasible to read the entire input first and then process it afterwards. We're going to read it in character by character. So char x, and we're going to want to have our pair pointer vectors east and south. Now, while x equals get char is not equal to -1, so long as we have not hit the EOF or end of file, if the character is a a new line, then we increment the row counter, set the number of columns to the current column counter, and then c equals 0. We reset back to the beginning of the line. Otherwise, if x is equal to the right arrow, then we add our coordinate pair to the east herd. So east.pushback, new pair rc, like so. It does not like that. Let me see if this compiles first. It does not. Okay. What if I use C++17? Okay, so that is fine. Let's just stick with this first. Okay, so yeah, we'll just do that. Okay, cool. And otherwise, if x is equal to the down arrow, then south.pushback, our new pair. And note that constructors like this will return a pointer to the newly created object. I'm not sure we can just do this. That probably doesn't work because this would actually return a pair and not a pair pointer. So we need to use the new keyword here. And finally, we increment the column counter each time. At the very end, we now know the number of rows. It is just the present row counter, like so. So now that we have read our input and we have our herds, we need to get our taken grid. And unlike the previous two languages, we don't have a representation of the actual original grid, so we cannot do any sort of map stuff. We will simply go through the two herds and just set the taken values to true. And this is actually why I'm using a taken grid and not a free grid, because we're going to initialize the taken grid on the stack. And so this part actually isn't strictly necessary, by the way. It will be initialized to all start at 0, representing everything being not taken. So now for each pair X in the east herd, we're going to set taken at that coordinate to be true. Now, what is this coordinate? Well, you'll notice that instead of making a 2D grid, I made a 1D array. My reason for that is simply so that you don't have to worry about any sort of casting stuff when passing it onto this here. Because do keep in mind that in C++, arrays are just a contiguous block of memory. They don't know their own size. So to be able to pass a 2D grid through, you'd have to tell it how wide it is so that the compiler can determine how much to offset by based on the index you insert. But we can avoid this problem by just doing that math ourselves, because it's not very hard. If we imagine that we've... Let me open up my whiteboard. If we imagine that we've just taken our grid and dumped it horizontally, then if our grid has indices 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then when we dump them out horizontally, they'll just be in order. And so if we're in column 2, row 1, then we notice that the coordinate is increasing by 4 each time. And so we can take the number of rows and multiply them by the number of, the row index and multiply by the number of columns. So that would give us 4. And then we add the column offset to get 6. And so that's exactly what we'll do. Row number times C plus column number. And so just for simplicity, let's define a macro for it. I'll just call it F because I'm lazy. It'll take the row and column and return R times C plus C, like so. So now here we can just give it F of the coordinates, where the coordinates are X first and X second, like so. We do the same for the south herd. Like so. And now finally, we do our loop for int I equals 1, empty statement, which is the same as saying true, I plus plus. If nothing moved, which we can do like so, I'll fill this out later, then we print out our loop index and break. So again, remember to use a single ampersand here, not double ampersand. We don't want short circuiting because we need to calculate both the east and south herds in every step and then check if none of them moved. So here we will give it the herd. Let me rename that. We will give it the herd, which starts out as east, the taken array, and then dr and dc, which are 0 and 1 for east. And then for the south herd, it is 1, 0, like so. So now, finally, let's finish up the move function. So we don't have something like filter or conditional list comprehensions. We'll just make a vector of pair pointers, which will represent the subset of the herd that is moving. So for each sea cucumber in the herd, let's deconstruct just to get R and C like so. It doesn't like that. Ooh, right, this is also a C++17 feature. Let's just not use that then. If it is not taken, then we will add the cucumber to M. Now what goes here? Well, we will use our f macro to convert our coordinates into the address here. And so that would be r plus dr and c plus dc, where r is the row index, so that's x first, and c is the column index, so that's x second. And now recall that the c cucumbers wrap around, so we need to do mod r here and mod c here, like so. Let's just simplify a bit, like so. And now that we have the vector of c cucumbers that are moving, we can do for auto x in M. Let's let r equal x first and c equal x second. This is because we'll need these values later. Like so. So now x first, since again we have a pointer, so we're mutating the same object that is contained within the herd itself. X first is now equal to this r plus dr mod r thing, and x second is equal to c plus dc mod c. And finally, we just need to clear up the old spot. So taken at frc is equal to false, and occupy the new spot. So f at x first, x second is now true. Finally, we just need to return something indicating whether or not anything moved. So we can just return m.size, the number of c cucumbers that moved. And so now let's compile that. And we run a.out with test.txt, and we get our intended value of 58. And if we run this on our actual input, we get 492. And unsurprisingly, this is the fastest of all of them, because C++ is just a faster language. Okay, so that was 2021 Day 25 C Cucumber done in 3 different languages. And if you watched all of them, first of all, thank you very much. You'll notice that the approach for all of them were basically identical. And there was sort of a point in me doing that. It shows that really what matters is your problem-solving skill and your ability to construct a logical solution. There will be differences in implementation. For example, I was... let me just bring up my solutions again. So in Python, for example, I used a filter list comprehension here. In JavaScript, I used the filter function. And in C++, I just ran a loop because there is nothing like filter. You'll notice, though, that in all of them, I mutated the actual value itself. In Python and JavaScript, I was able to just pass by reference. And in C++, I just used pointers. But ultimately, the core logic was the same. Get our grid, determine where the C cucumbers are, find our taken grid, make a function that allows us to move our herds easily, and then just run a loop checking if anything in the herd moved. So with a problem like this that's a bit more advanced, hopefully I was able to show you a bit of the thought process that goes into how I solve these problems, and hopefully you'll be able to apply some of the tricks that I used throughout in your own problem solving. So that wraps up this video. It is quite long, so if you watched the whole thing, thank you very much. I appreciate the support. Don't forget to like the video if you enjoyed it, and subscribe if you'd like to see future videos from my channel. And thank you very much.